Listeners, this is Hardik Pradhan. First, I will like all of you to subscribe this channel, subscribe to watch this kind of video about many topics in mathematics for all levels. So subscribe this channel. And if you like this video, then comment me what you likes your dislikes on these videos. So comment me and continue watch these videos and share with your friends. So let's start. I'll today discuss about probability mass function and probability density function of statistics. So let's go start. First we discuss probability mass function. Probability mass function. It is a function. Probability mass function is such kind of function which takes values of variables. Variables also can take values, and depending on the values, uh, the probability mass functions arises on on a plan. Such kind of diagram can be structured in this way. Here, x is a variable which takes many values, um, and different values, and this is the probability mass function. This is a function fx. So it is probability mass function. Actually, I have also launched a video on statistics. There I have discussed what is a discrete type and what is a continuous type. So discrete type of variables always will take probability mass function. So discrete type means finite values always we will get for x by x, and for depending on this x we have a frequency which is called probability mass function. So it can take, I am giving an example to understand this. Take there is a coin, it have only two possibilities. Either its sample space will be coin, its sample space will be head and only tail, head and only tail. So if I take two coins, then the sample space will be coins, then the sample space will be, can be head, head, one head, one tail. First coin may be head, and the other coin may be tail, or first coin may be tail, and the other second coin may be head, or both coin have tails. This is the fourth outcomes. So these are the maximum outcomes. Not more outcomes you will can get from tossing two coins just. So here for having a head, the probability of having a head, having a head, one head, at least one head, having one head, can be, there are three outcomes. Here is also head, here is also head, and here is also head. So having one head, it can be 3 out of 4 outcomes. So probability is 3 by 4. Now, having one head is 3 by 4. If you take just only one head, only one head, then there are only two possibilities, which are a head tail and tail head. So there will be 2 by 4. And one more, if I have a condition that if both the faces have same values, and both the faces have head or both the faces have tail, uh, both the faces have head or both the faces have tail, I am taking one. Both the faces have head. Both the faces have head. Then there is only one possibility. Have head. Then there is only one possibility, and this is just head head. So this is 1 by 4. So if I put these datas, I am taking this is 1, this is 1 by 2, this is 1 by 2, this is 3 by 4, this is 3 by 4, and this is 1 by 4, this is 1 by 4, and this is 1. So for 3 by 4, actually the diagram will be changed. The diagram will be x can take values. I am giving x can take values of heads. So uh, here x can take one head or two heads. Here there is one head, this is one, two, and there cannot be more values. Here x can take head. So now for if I will here break, this is one, 1 by 4, this is 2 by 4, this is 1 by 4, this is 2 by 4, this is 3 by 4, and there is 1 if I break. Then for having one head, this will be 3 by 4. So here I will get a point. And for both the faces have head, we will get 1 by 4. There will be a point. So the curve will be in this way. In this way. If there is 0 heads, so no outcome have 0 heads. If you will take x0, then the probability is 0. So the curve will be in this way, and when so in this way, I have taken the probability mass function. This is called the probability mass function. Depending on the different value of Ax, the probability mass function is drawn. Now, I wish to know the uh, distributive function of the probability mass function, which is called cumulative distributive function. Cumulative distributive function. So, what will be cumulative distributive function? So, if I take 1 for value ax, then what will be the distributive function up to 1? So, up to 1, the value will be in this way. Cumulative distributive function up to 1, here up to 1, summation up to 1, and this will be fx and x. So here up to 1, uh, this is x. So the value of up to 1 is fx is 3 by 4, 3 by 4, and the value of x is 1, sorry 1. So this the cumulative distributive function will be 3 by 4. So up to n 1, the cumulative distributive function is 3 by 4. Actually the area, this area is the cumulative distributive function up to 1. This area is the cumulative distributive function up to 1. Here in this area, this distributive function and this cumulative distributive function shows that here uh, one heads happened. Just one head is happened in this area. So this is the cumulative distributive function. Now, if I take up to 2, then the cumulative distributive function will be more. This will be up to 2. It will be cumulative distributive function up to 2. It will be up to 2. This will be fx and x. So here we will take first up to 1, then this will be f1 f1 into 1 plus f2 up to 2. So will I put these values 1 for 1, this is 3 by 4. So 3 by 4 multiply 1 is 3 by 4, and this is 1 by 4. Multiply 1 is 1 by 4. So it will total 1. So if we will take this area, the cumulative was up to 2, this will be the whole area. Yeah, this area and the green area and the yellow area, both the area is the cumulative distributive function up to 2, and the cumulative distribution up to 1 is the green area. In this way, probability mass function and cumulative distributive function are known to or in statistics. So, there are discrete values. For 1, there is a discrete value 3 by 4, and for 2, there is a discrete value probability mass function is 1 by 4. This way, probability mass function is uh, applicable for just discrete values of any statistics values. And the difference in the probability mass and probability density function, probability density function, probability density function actually applicable on continuous type of data. Density function. Probability density function. Here the diagram is different and is of continuous type. Means the data are of continuous type and the probability density function is of continuous type. So if I give an example, then you can very easily understand. Like age of students in a school, age of students in a school, age of students in a school. I'm drawing the range first. First, between 10 to 12, there are 10 to 12 years. There are I am taking 100 students, and between uh, 12 to 14 years, I am taking 150 students, and between 14 to 16, there are 200 students. So, how it can be drawn in a diagram? In a diagram, there is x and there is fx. So, we will take 10 to 12. This is 10 I am taking. This is 12. This is 14. This is 16. So here this is 50. This is 100. This is 150. And this is 200. Now, if I put these data, then for 10 to 12, it will be 100. So, there is a straight line from 10 to 12. This is 100. It is with the S10. Then, with 12 to 14, there will be 150. Then, it will be 150 up to 12 to 14. And then, for 14 to 16, this will be 200. This is 200. In this way, we have drawn this curve. This curve drawn on the plan. This curve I am drawing with yellow, with green. This curve actually is the probability density function. This is the PDF, probability density function of the given data. It is, you can look this. This is a continuous, and this is continuous type. Here, the activity distributed function can be calculated in this way. Think that we used to know the cumulative distributed function CDF is written in this way. Capital Fx, this is given by integration minus infinity. I used to know up to 12. So up to 12, this will be Fx and this will be dx. So here Fx is 100. We can understand that this line is the actually Fx is here just 100. You can know from the Cartesian geometry that the straight line from up to this range, if we take here actually minus infinity to 12 means we can take 10 to 12. So here the straight line represent Fx, means probability density function is Fx equal to 100. So here 100, it is a constant and not dependent on x. It can be also that the variable, it can be here it is a straight line, but it may be that it not a straight line or parallel to x-axis. It can be, I am giving another example to understand that it cannot be parallel always through x-axis. Here it is x-axis independent of ax because it is parallel to x-axis. But in another example, I will show you that it cannot be parallel to x-axis. So there is 100 is a constant, and we will have ax. So x means here will be 12 minus 10. This will be 2. This will be 2. So this is 200. Here the distributive function is unit distribution is 200. So this will be the cumulative distributive function here up to 12. This will be the cumulative distributive function, and in this way you can out up to 14 you can bring out this cumulative distributive function. It will be just 200, and here we will get 300. So 500 you will get for this cumulative distributive function. And at last, if you will up to complete this up to 16 age, if you will find out the distributive function, then you will get 900. So total 900 students you will get in the distributive function. Total 900 students. So in this way, probability density function are defined, and the cumulative density function can be obtained. So I'm giving another example to make it clearly understood. It can be that the cumulative density function, the probability density function can be straight line in this way. The cumulative density function can be the probability density function for any problem. It can be y is equal to afx, means fx probability density function is equal to a, and there are many values. I am taking this is 1, and this is 2, this is 3. So up to 3 we can take the cumulative distributive function. So I am giving the cumulative distributive function. I want to know up to 3. So what will be the cumulative distributive function? So this will be the cumulative distributive function fx will be here integration needed to complete because it is a continuous type. So integration, and for the probability mass function this is of discrete type, so there needs summation up to 3. I am taking the whole region through differential calculus. You can clearly understand why it is taking integration fx and dx. So here I have said that here the fx is not a or is not parallel to x-axis. So what will be fx? Fx will be a x. Yeah, fx is x. Then it will be changed. Minus infinity to 3 means here is 0 because there are no values after 0. So we will put here 0, not minus infinity to 3. If you have known lower limit or upper limit, then you can put this fx is x and this is dx. So you get x square by 2, x square by 2 up to 0 by 3, the limit 0 by 3. So we will get 9 by 2. So this 9 by 2, this distributive function for any problem which probability density function is defined in this way, and this its cumulative distributive function up to 3 is 9 by 2. So in this way probability mass function, probability density function, and the distributive function, cumulative distributive function are defined in the statistics. I hope you like this video, and if you like, then like this video, subscribe this channel, and comment me. Of course, certainly of surely uh, comment me and subscribe this channel to get such kind of videos. So thanks for watching. I hope you liked, and share with your friends. Have a good day.